In the previous lecture, we saw that how the function gets the output from a given input. When we give input in form of a number, it is processed numerically or mathematically by a function, and then the output is granted. So the function is clearly and completely defined in the previous lecture. Welcome to lecture 1.3 Mathmagic 2.0 Reinventing Calculus. In this particular lecture, we will be talking about the types of functions, that how the functions and the life activities are related to each other. So let us look to that we know that there is a function f p. Say for example, the input given is p and the output taken is q. This function is giving the output q and the input is p. So let us look to the very first kind of function, and that is the constant function. Now the constant function, if I look to the input p and if I look to the output, that is q at p. If the input is, say for example, 1, the output is 10. Even the input is 2, the output remains 10. The input is 3, the output remains 10. The input is 4, the output remains 10. If I draw or if I plot, we'll have the p, because p is the input and q is the output. The basic behavior of this function would be constant. Means for p being 1, the output is again 10. For p being 2, you can very well see for p being 2, the output is again 10. For p being 3, the input being 3, the output again 10. Means the behavior of the function is constant. It is something similar to a stationary object standing and the distance is remaining the same even the time is being elapsed. Another type of function would be the identity function. Identity function. Now these type of functions are a unique kind of functions in which the input, say for example, the input is p and we are taking the output as q. So the input is 1 and the output remains 1. The input is 2, the output is 2. The input is 6, the output again becomes 6. If I plot this, once again, it will be a linear line or it will be a straight line because it is varying evenly. The input is 1 and the output is also 1. The input, as I said, p and the output is q. The input, if it is 2, the output is again equal, same. So the function states that input is equal to the output. This is nothing but the identity function. The input becomes 6 and the output is also 6. There are certain functions, the functions which are power functions. Now these power functions are in a way that the input given, the function would be of having a power. Say for example, the input is 1, the output would be 1 square. If it is power of 2, the power is 2 out here. If the input given is 2, then the function would, because it's a power oriented function and it is getting you the square, it will give you 4. The input given, if it is 3, then it will generate as an output the square of the input and will give you the output as 9. If we plot these kind of functions in a positive side, it will be somewhat curvilinear. There are two kinds of power function, that is the even power functions and the odd power functions. Now the even power functions would have the powers of 2, 4, 6 and so on and so forth, whereas the odd power functions would have 1, 3, 5, means here it will be p to the power 4 or here it will be p to the power 3 or p to the power 5. The behavior would vary. The behavior would vary. Now if I take a scenario, if I take a situation once again, for the input given, say for example we consider input to be given as x and the function is plotted on the y-axis or on the vertical axis and the function output is y. We can very well say that y is equal to f of x. Now this is the function. If it behaves in a fashion, now this behavior is depicted by the function fx, and you can very well find out that for this particular input, that is x1, this would be the output, and that is nothing but y1, and that is nothing but f of x1. If it is at point 2, x2, then the output can be very well seen onto the vertical axis, and that will become y2 is equal to function at x2. Another function is a modulus function. Now let us look to this function. When we talked about an identity function, that if the input given is 1 and the output is another 1. So this was the pattern or behavior of an identity function. If the input given is -1, if it is in negative, the output would again be -1. So it behaves like this. But modulus function states that fx or the function would be mod of x. This means that non-negative value This says that it cannot go in this direction and it will have its presentation in this direction. This would be a straight line. This is a modulus function. There are certain functions called exponential functions. Now these functions are having an exponent. There will be a constant and there will be an exponential power to it. Now these functions will be fx is equal to the exponential function. The behavior of this exponential function, if we take rather that let a be equal to 1 by 2. Let the input be x and the output be y. Now the x, as we know that the input to the function, say for example it is given as 1, and we know that output y is nothing but a to the power x. That is, a, as we said, is 1 by 2. For this input 1, the power would be 1. So it will be 1 by 2. If the input given is 2, it will be treated in a way that then it becomes 1 by 2 to the power 2, because this input is 2 over here and this will make it as 1 by 4. If I see to the negative side of it, maybe on this side, if I plot it as -1, the input given is -1, it means it would be 1 by 2, because this is our a and the power would be -1. This would be then taking this denominator to the numerator, and this would be 2. So for -1 it would be 2, and so on and so forth. For 1 it was 1 by 2, means when the input or the x given is 1, it was half. Say for example this is 1, this is half, so the point lies over here and the behavior would go something like this. There are certain functions which are known as circular functions. Now these functions are meant for repetition when an happening or an event is repeating. Maybe in terms of pendulum, in terms of your circular motion, these functions are sin x, cos x, tan x, tangent x, and so on and so forth. These would always have a repetitive nature in terms of input, and the output would be repetitive in nature. I'll talk about these functions as and when required, because these are very, very important kind of functions. See, as we have seen that what exactly is a function, and we have seen certain types of function. There are various types of function available. We cannot discuss it all right away, right here. I've discussed some of the most commonly used functions. We'll be looking to the functions in coming modules as and when required. In the next module, we'll be talking about limits and continuity. We'll be looking technically more, and we'll be looking to the deeper insight about behavior and rate of change. I'll see you in the next module. Thank you.